Hi, 8th grade. Welcome to your last lesson of Topic 5, Lesson 5-4, Solve Systems by Elimination. At the end of the lesson, I want you to be able to say, I can solve systems of equations using elimination. Let's solve and discuss it. A list of expressions is written on the board. How can you make a list of fewer expressions that has the same combined value of those shown on the board? Write the expressions and explain your reasoning. Okay, so I'm choosing to combine like terms. I see I have a negative 3y and a positive 2y. So we could write that as negative 3y plus 2y. Then I also see some x's. I see a 3x, a negative 2x, negative 5x, and a 5x. Well, right away I see negative 5x and 5x are opposites. They cancel each other out. So I'm left with positive 3x and negative 2x. And lastly, I have some constants. So I have a 5 and a negative 3. So plus 5 minus 3. Combining like terms, negative 3y plus 2y is negative 1y. Positive 3x minus 2x is positive 1x. And 5 minus 3 is positive 2. So I just took 8 terms and made it 3. Two expressions have a sum of 0. What must be true of the expressions? They must be opposites. The same numbers, but one positive and one negative. Okay. Example number 1. Solve a system of equations by adding. How can Remy use this system of equations to solve the riddle? 2 times the number x plus the number y equals 8. That's where they get this equation from. 2 times the number x plus y equals 8. 4 times the number x minus the number y equals 4. 4 times the number x minus y equals 4. Well, it's written right up and down from each other, which is what we want. And we want the x's on top of the x's, y's on top of the y's, and constants on top of the constants. So we can add straight down. 2x plus 4x equals 6x, and we see a positive y and a negative y. They cancel each other out. 8 plus 4 equals 12. And solve for x, so we got to divide by 6 on both sides. X equals 2. But we're not done. Remember, we're trying to find x and y. So you choose one of the equations. It doesn't matter which one. They chose the first equation, so they wrote 2, and instead of x, they put in a 2, because that's what we just found out that x was. And 2 times 2 equals 4, plus y equals 8. Subtracting 4 from both sides, cancels out on the left, and we get y equals 4. So the solution is 2, 4, or x equals 2 and y equals 4. Use elimination to solve the system of equations. Well, if we look, they are right up and down from each other. The r's on top of the r's, s's on top of the s's, constants on top of the constants. Now we want to look to make sure one of the variables will cancel out. The only way it'll cancel out is if we've got opposites, and we can see that with the s's. There's a positive 3s and a negative 3s. So we add 6 plus 2 is 8r. Positive 3 and negative 3 give us 0. And 14 plus 6 equals 20. So trying to solve for r, we got to get rid of the 8. So we're going to divide by 8 on both sides. So r equals 2.5. Again, we're not done. We have to solve for s. So we pick either one of the equations. They chose the first one and wrote it for us. 2r, but instead of r, we just found that r is 2.5. So we can plug that in, substitute it in. 2 times 2.5 is 5, plus 3s equals 14. To get the s alone, we first have to subtract by 5. So 3s equals 9. Divide by 3 on both sides. And s equals 3. So r equals 2.5 and s equals 3. What must be true about a system of equations for a term to be eliminated by adding or subtracting? They must have the same coefficient. The same coefficient with the same variable. All right, example number 2. Solve a system of equations by subtracting. I never want you to do this. I don't want you to subtract. I'll show you. We're going to do addition all the time. But I'll show you what it looks like with this example. Hannah is helping her younger brother, learn to count money. She gave her brother a total of 20 coins, nickels, and pennies. Hannah's brother said he counted 68 cents. How can Hannah solve a system of equations to tell whether he counted the money correctly? Write a system of equations to relate the number of nickels and pennies. So it says let x equal the number of pennies, let y equal the number of nickels. X plus y equals 20, because there's nickels plus pennies equal 20 total coins, and x plus 5y equals 68, because pennies are worth 1 cent, nickels are worth 5 cents, and there was a total of 68 cents. So I don't want you to worry about their step 2 and step 3. We're going to do with adding. But remember, we have a problem when we're trying to cancel out. I know my x's are going to cancel because they're both 1x, but I need one to be positive and one to be negative. So what we're going to do is we're going to multiply one of the equations, it doesn't matter which one, by a -1. That will turn our x negative. But whatever you do to 1, we have to do to every single thing. So what I want you to do is rewrite the equations. So the first one, nothing happened to. 1x plus 1y equals 20. Now distributing that -1. -1 times 1x is -1x. -1 times positive 5y is -5y. And -1 times 68 is -68. So now we're adding just like we did in the last example. 1x minus 1x, that cancels out to be 0. 1y minus 5y is -4y. And 20 minus 68 is -48. So then to get y by itself, divide by both sides by -4. That cancels, and y equals 12. Remember, we're not done. Once we solve for one of the variables, we have to plug it back in to either equation to solve for the other variable. So again, it doesn't matter which one. I'm going to choose the first equation just because it's got less work to it. So x plus, instead of y, we can put 12 equals 20. Solving for x, I subtract 12 on both sides. This cancels out. Bring down the x equals 8. And look, 8 pennies, 12 nickels. That's exactly what they said. Keep to the adding. If we do it the same way every time, it leaves less room for confusion and simple mistakes. Solving a system of equations by multiplying. The difference of the length and width of the rectangle is 3 centimeters. What is the length and width of the rectangle? Write a system of equations to relate the length and width. So we know that the perimeter is 26. So that's why they have 2 times the L plus 2 times W is equal to 26. And they also said the difference between the length and the width, remember difference means to subtract, is equal to 3. That's how we got this equation. But you would say, Ms. Justinger, you said in order for them to cancel out, we need them to have the same number in front. And they don't. We've got a 2L and an L, a 2W and a W. So we need to multiply one of the equations by a number in order to get them to cancel out. I also want to pay attention to making sure one of them is positive and one of them is negative. So I see my 2W and my W. The 2W is positive, the negative W, or the 1W is negative. So I'm going to multiply the bottom equation by 2. So once you multiply, I want you to rewrite it. So the first one, nothing happened to. 2L plus 2W equals 26. And now remember, when we multiply, we distribute to everything. So 2 times L is 2L. 2 times negative W is negative 2W. And 2 times 3 is 6. Now we can add downward. And they show us that right here. That's what we just rewrote. 2L plus 2L is 4L. 2W minus 2W cancels out. 26 plus 6 equals 32. So now we divide both sides by 4. That cancels out, and L equals 8. remembering that we're not done once we solve for one variable. Got to solve for the other. So using either equation, second one looks easier because there's less numbers, less work to be had. Instead of L, we're going to write in 8 minus W equals 3. They skip some steps. Let me show you them. 8 minus W equals 3. Subtract 8 on both sides. So we get negative W equals negative 5. And we can divide both sides by negative 1. So W equals 5. So the length of the rectangle is 8 and the width is 5. Let's try it. Use elimination to solve this system of equations. So I have two equations. The x is on top of the x's, y is on top of the y's, 9 on top of the constant on top of the constant. So can anything cancel out right away? No. So we need to multiply one or both of the equations by a number to get them to cancel out. The easiest way to do this is to multiply the bottom equation by negative 3. Doing that will get the x's to cancel out. So we're going to distribute to everything. Rewrite the problem. 3x minus 5y equals negative 9. Because nothing happened to the first equation. Now we distribute. Negative 3x, negative 6y equals negative 24. Now we can add 3x plus negative 3x cancels out. Negative 5y plus negative 6y is negative 11y. And negative 9 plus negative 24 is negative 33. To solve for y, we are going to divide both sides by negative 11. This cancels out, and y equals 3. Not done. Again, pick equation, doesn't matter which one, both will work. I'm going to use the bottom one, seems easier. X plus 2, instead of y, I'm going to put 3 equals 8. PEMDAS, I'm going to multiply first. X plus 6 equals 8. Subtract 6 from both sides. This cancels. X equals 2. So our solution is 2, 3. Cool. All right, 8th grade, let's say it. I can solve systems of equations using elimination. Have a great day.